afternoon, everyone. I'm John Prewer, a former architect, and I'm now the CTO of Airponix Ltd, which is developing an advanced technology aeroponics system. I've been an innovator most of my adult life, focusing mainly on three technologies under the broad headings: energy, shelter, and food. I pioneered the development and commercial use of aeroponics in the UK in the mid-1970s and early 1980s. I filed my first aeroponic patent in 1976 after achieving my first aeroponic success when I grew a dozen lettuces from seed to kitchen table ready condition in only 22 days. In 1982 I grew crops of potatoes and tomatoes, and in 1983 grew PYO strawberries using my aeroponic system in association with a commercial grower on the Isle of Wight. An aeroponic system consists of four subsystems: a low-cost protective enclosure stroke structure, in our case a revolutionary type of fog generator, an environmental sensing forward/control unit, and a seeding self-harvesting device. The low-cost protective enclosures isolate the growing plants from weather and biological threats. They consist of equilateral triangular section growth chambers, typically 1.8 meters high and wide and 30+ meters long. The enclosure envelopes are made from plastic films draped over and clipped to tension ropes. The ropes form suspension-like bridge structures which can be easily adjusted to control the height of the growth chambers above ground level and the spacing between adjacent growth chambers. A valuable feature of the enclosures is that they can be used for growing grain crops such as wheat and rice, even on steep slopes. Fog blown uphill inside growth chambers and dry, ripe grain will slide down. From the very beginning of my work on aeroponics over 40 years ago, I've used fogs rather than mist to supply nutrients to the plants. It is, I'm certain, the way fogs are generated and the ways they can be used which holds the key to the future of large-scale aeroponic farming. For that reason, most of my time working on aeroponics in recent years has focused on finding better ways to make fogs and new ways to use their truly extraordinary potential for optimizing plant growth. Here I should explain that through my early aeroponic experiment, although my early aeroponic experiments usually work well, sometimes spectacularly so, the main problem was always the large amount of energy needed to create the fog droplets capable of performing over a dozen different functions effectively and with total reliability. The pressure drop in the first fog nozzle types I used was 14 bar. Today, our aeroponics fog generators operate with a pressure drop of only 150 millibar, i.e. a 93 times reduction. Aeroponics fog generators are specially modified versions of print heads found inside most home printer stroke copiers. So although they are engineered to meet a very demanding performance specification, they're cheap to purchase and extremely reliable. They have a clear, unlimited or near unlimited working life due to their high blockage resistance. They use no moving parts, they use very little energy, have a high degree of control over droplet size and frequency, are easily scalable, add positive or negative charges to droplets for Airponix electroculture growth stimulation method, which incidentally was pioneered by Hampstead here between the two world wars, and use a multiplex system, which is an extremely simple and inexpensive one to manufacture in quantity. There are 13 currently aeroponics fog functions which increase yields or protect plants. Unfortunately, because of time limitations, I've only got time to mention three of them. One is foliar feeding using 0.5 micron diameter droplets, which are capable of entering the stomata. Antibacterial effect using negatively charged droplets, a system originally developed in the States, and droplets containing RNAi, which are delivered to either roots or leaves or both. Airponix has recently concentrated on investigating ways to improve its system's climate change effects, resilience, growth enhancement methods, and new low-cost, environmentally friendly materials for constructing growth chambers and their support structures. The Aeroponics system in its fully developed form will make it possible for the first time to grow staple crops, such as rice and wheat, aeroponically, which will compete strongly on sustainability, resilience, quality and cost with conventional farming methods. What have we learned along the way? Well, it usually doesn't pay to be too far ahead of other technologies in the same field. I was 40 years too early with my system of aeroponics. Okay.